All right, welcome to section 4.2. As you can see right here, the title of the unit circle, many of you have probably heard about students talking about it. It's a super important thing that really is just going to carry through. And as we go through the construction of it right now, what I want to just preface by saying is what we do right now in the notes is the development and sort of the theory and the math behind the unit circle. But then what we're going to do at the end is just give you the whole unit circle, and it's all stuff that you have to memorize because you're not going to be doing this work on a regular basis. So when we're talking about a unit circle, we're going to consider the circle given by the equation x squared plus y squared is equal to 1. And what this is really saying is that the radius is 1 and the center is at the origin. If you sort of remember your equation of a circle there. So it's a unit circle because it's a radius of 1 unit, where each coordinate, x comma y, is a point that's on that circle. So what we're going to be doing is mixing trig to try and come up with the points or some points on that circle. So at any given point on the circle, imagine the radius being drawn from the point to the origin. So for instance, the point that we're going to do first is this point. And here what we have is a radius being drawn to that point from the center. Well, I know that the radius has to be 1 unit because r is equal to 1. In this case, it's a unit circle. The angle that we're going to talk about first is the angle that's 30 degrees. I guess I don't need the degree sign since it says it right there. Or pi sixth. Those are the same thing. And what we're going to do is imagine if I was drawing this right triangle. And then we're going to do some right triangle trig. So you guys learned last year when we have a 30, 60, 90 right triangle. Opposite of the 30 is where you would have n. Opposite of the 90 is where you'd have 2n. And opposite of the 60 would be n square root 3. So if 2n is equal to 1, that means over here we'd have a height of 1/2. And over here we'd have root 3 over 2. You're thinking about 1/2 times square root 3, which is root 3 over 2. So I'm able to get the dimensions of that triangle. Now, if you put this back into the idea of the circle, well, what we just found is that the length from the origin to that dotted line was root 3 over 2. And the height going upwards was 1/2. Since this would represent the distance that I have traveled in x, and this 1/2 would represent the distance I've traveled in y, this coordinate would be root 3 over 2, comma 1/2. So now I know a coordinate on the unit circle, root 3 over 2, 1/2. And that happens at 30 degrees. But what we're going to do is connect some trig to this now. So I have this right triangle, this 30, 60, 90 right triangle. And if we talk about or think about sine, cosine, and tangent, when we learned them back in geometry, we said that sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. So now, if I'm looking at that right triangle and I said, well, what is the sine of 30 or the sine of pi sixth? Same thing, again, just different notation for the same angle. Well, the sine of that would be the opposite side over the hypotenuse. So I'd have 1/2 over 1, which is just 1/2. What is the cosine of 30 degrees or the cosine of pi sixth? Well, that's the adjacent side over the hypotenuse. So root 3 over 2 over 1, which is just root 3 over 2. And the tangent of 30 degrees, or the tangent of pi sixth, is opposite 1/2, and this one I'll write out, over the adjacent, root 3 over 2. And if you're not sure what this turns into, well, when you're dividing by fractions, you multiply by the reciprocal of this, so 2 over root 3. The 2 over 2 cancels, so I'm left with 1 over root 3. And then we always rationalize, so multiply by square root 3 on top and bottom. This gives me square root 3 over 3. So sine was 1/2, cosine was root 3 over 2, tangent was root 3 over 3. We could notice sort of a parallel here. The sine of any angle is going to be equal to the y coordinate, or sorry, the y value of the point on the unit circle. So notice in sine we had gotten 1/2, which is also what we said was the y value on the unit circle. Cosine is going to be the x value of any point on the circle. So again, going back, our cosine or our x value here was root 3 over 2. And when we looked at that right triangle, we said, well, our cosine would be root 3 over 2. An easier way, well, let's do one step first, sorry. The tangent of any angle will be y divided by x. So whatever my y value is over my x value. And you can see that here I did my y value over my x value. So sine is equal to y, cosine is equal to x, tangent is equal to y over x. This is all stuff that you have to memorize. You have to know that sine is the y value, that cosine is the x value. And if you think about it, you list coordinates as x, y, which is in the order of cosine, sine. Both of those are alphabetical. So x then y, cosine starting with c comes before sine. The reason people sometimes struggle with this is that you're so used to thinking about your trig functions as sine, cosine, tangent. Say, wait, it's listed here. So people look at a coordinate and they say, oh, sine, cosine. No, alphabetical, cosine, sine. All right, so moving along, we want to talk about some of the other angles that are going to be important. So the next one that we're going to talk about is 45 degrees, which is the same as pi fourths. Again, if we were to draw this triangle, so now we're talking about this angle. And what I'm doing is pulling that triangle out so that we could just look at that. So I've got 1 and the 45 degrees. If you're thinking about your setup for 4590, it goes n square root 2. And if you were solving for n, you would say, okay, n square root 2 equals 1. So n equals 1 over square root 2. And you rationalize that, so n equals root 2 over 2. So each of these sides will be root 2 over 2. Again, this is just right triangle trigonometry from geometry, nothing new. It's like it's not even honors pre-calc at this point, except for this little pi fourths. No, that's new. So now if I were asking for the sine of 45 degrees, well, sine is opposite over hypotenuse. And the hypotenuse is just 1, so it's really just opposite in this case. Root 2 over 2. Cosine is adjacent over hypotenuse, so root 2 over 2. Tangent is opposite over adjacent, so root 2 over 2 over root 2 over 2. When I have anything over itself, I just get 1. Well, now if I was listing this coordinate, it goes cosine, then sine. So root 2 over 2, comma, root 2 over 2. In this case, it wouldn't have mattered. Now, this is for every 45 degree angle. You know, if I talk about the sine of 45 degrees, it's root 2 over 2. Every single time. Okay, the next angle we want to look at is 60 degrees. So this is going to be the next one that's going to be on our unit circle, something that we're going to have to memorize. If you're thinking about, and this is also pi thirds, if you're like, well, wait a second, Mr. Davis, like we skipped over like 20 degrees and 35 degrees. Those are not things that we're going to memorize. We're just going to memorize 30, 60, 45, 0 and 90, and then sort of all the multiples of those. So Again, if we were drawing this triangle, here's my 60-degree angle. So right here, I've got my 60-degree angle, my pi thirds. So I'm pulling out that right triangle here. Your setup in a 60-degree angle is still n square root 3, 2n, n. And if this is 2n, then I have 1/2 down here, and root 3 over 2 as my height. So if I want the sine of 60 degrees is opposite over hypotenuse. So root 3 over 2 over 1, which is just root 3 over 2. The cosine is adjacent over hypotenuse. So this is just 1/2 over 1, which is 1/2. And tangent, you set sine over cosine, or y over x. So root 3 over 2 over 1/2. And you could either multiply by the reciprocal, or when you see that you have two fractions that are being divided and they have the same denominator, that denominator will end up canceling. So I'm left with root 3 over 1, which is just root 3. Well, how does this help me? Now I know this next coordinate on the unit circle. Again, it goes cosine, then sine. So 1/2 root 3 over 2. You'll notice looking at these two, they are just flipped. And that makes it easy to remember because you don't have to remember totally new numbers, but you do have to remember that this one comes first. What happens for a lot of people is they end up switching these coordinates. But if you look at sort of the y values, this goes 1, 2, 3, or going with the x values, 1, 2, 3, going downward. So it'll be sort of up to you to think about how you want to disseminate that. You just look real quick. I don't know if we cover it in the next slide. So TBD, just wait like a minute. Okay. What about 90 degrees or pi halves? If we were talking about 0 degrees or 0 radians, these being the same spot, or 300 degrees or 2 pi. So all of what I just underlined there in red is talking about this coordinate. This is 0 degrees. It's also 360 degrees because 360 degrees means I go around this whole circle and I'm right back here. So what I want to do is figure out the sine, cosine, tangent of these. Well, something to keep in mind is that this is a unit circle, which means the radius here is 1 unit, which would make this coordinate 1, 0. This coordinate here, since this is a unit circle, I'm going up 1, so this is 0, 1. So now if I want the sine of 90 degrees or the sine of pi halves, again, those being the same, I need to look at the 90-degree angle, this one, and sine is my y value, so it would just be 1. Cosine of 90 degrees or cosine of pi halves. Cosine is my x value, so 0. And tangent of 90 degrees or tangent of pi halves, you do y over x. So 1 over 0, which is undefined. If I want the sine of 0 or the sine of 2 pi, so now we're talking about this location. This is 0, it's 2 pi, it's 360 degrees. Sine is the y value, so 0. Cosine, the x value, 1. And tangent is y over x, so 0 over 1. 0 over 1 is 0. You'll notice that these are just switching from each other. So the sines of 90 was cosine of 0. The cosine of 90 was the sine of 0. And the tangents went from 1 over 0 to 0 over 1. So it switched it from undefined to 0. Make sure you have these coordinates down. These are one thing that, for some reason, people just get mixed up. There's so many things you're going to be memorizing that people overlook this. So what we've gone through in this whole video, and I'm going to re-summarize here, is the entire quadrant 1 of the unit circle. So that's what we're going to write out. In red, I'm going to start by doing just the degrees. This is 0 degrees, or if you would prefer, 360 degrees. It's sometimes helpful to have both of those just so that you realize they're the same. Then it goes 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Next, I'm going to do my radians. So this is 0 pi, or 2 pi. This is pi sixths. So one thing that happens here is the numbers are going to switch, 3 and 6. So degrees, it was 3, so radians is sixths. Here I have pi fourths, 4 and 4. Here I have pi thirds, and it's that same idea of switching. The degrees is 60, so the radians is out of thirds. The degrees is 30, so the radians is out of 6. Here I have pi halves. Remember that pi is the entire semicircle, so you're talking about what portion of the semicircle you have. Next, in pink, I'm going to list what these coordinates were again. So this was 1, 0. This was root 3 over 2, 1/2. This was root 2 over 2, root 2 over 2. This was 1/2, root 3 over 2. And this was 0, 1. And last, in a new color, let's do purple, we're going to do the tangents. So the tangent for this is going to be 0. The tangent for this was root 3 over 3. The tangent here was 1. The tangent here was root 3. And the tangent here was undefined. Oh, okay. Well. And then what I'm going to do is just label some important stuff. And we'll do that in this wonderful green. So this was cosine, sine, tangent. 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 Most people are not going to struggle with the degrees. Most people are not going to struggle with what's in blue, the radians. What happens is people really struggle with the pink and the purple parts of this. And you should or could try to recognize that there is a pattern. So if you specifically looked at something like the y values, it goes 0, 1 on top, that's fine, 1, 2, 3, and then you get the 1, but you should know that coordinate anyways. Going the other way, 0, 1, 2, 3. So come up with whichever way you want to try and memorize this and figure out the pattern in which that's going. But make sure that you get that down. In terms of the tangents, 0 is a really small tangent. 1 is like in the middle here. You could tell this point is in the middle. Square root 3 is like approximately like 1.5 or something. So this is actually increasing these purple parts. It's going from 0 to whatever this is divided by 3 to 1 to something larger than 1 to being now totally undefined. So this is our first quadrant unit circle. In all of the work that we did, all we really went through was the development of it. And if you forget that development, I'm going to say, okay, I don't love it. You should remember it. But what you have to know is all of these points. You could switch the order, whatever, but you have to know that 60 degrees is pi thirds, has a cosine of 1/2, it has a sine of root 3 over 2, and a tangent of square root 3. And you want to try and get this down as fast as you can because you have all of quadrant 2, quadrant 3, and quadrant 4 as well. But those are just sort of reflections of this same pattern. So if you don't know quadrant 1, you're sort of doomed for quadrant 2, 3, and 4. All right, so get to some memorizing. And then if you want, you can start watching day 2 video where we're going to go through some other, some other important stuff about the unit circle, and also fill in quadrant 2, 3, and 4.